So doing that,
Not really bad.
I got asked to pay for this kingdom.
I hear a sound.
I mean, honestly, it's like pretty simple.
He's literally just.
Exactly what my job.
Let me see, do I have to?
And then again, so like
Maybe do I have to?
511 ATMS.
Right, try it.
Making certain full traffic incident, ITS.
That was so when I just clicked on the actual screen.
Like,
Like you have to like reset. So, okay, well, that's good to know. Yeah, sponsorships like back up, I guess. There we go. Should be good. Perfect. Thanks, man. No problem.
So I took that in December. So again, it's on the. Hey, things going on. Speaking of, introduce myself to clients. I'm sure they're all happy. So, like right now, it's a lot of just like. Make sure that it's not blocking, so it's not happening. Like a bunch of projects that are out there. I don't know. And then a few projects out in California, one Florida that are finishing up. And it is, and then I just really good at. Development. Yeah, the last. And yeah, like, you may have, like, I've been helping on a couple of projects. And so there was a 2-day period, and everybody was like, well, I guess this has been happening in the wars and shut down, and then it's like, make your coffee. So that was a fun. Wasn't even a full, so 48 hours, like 36 hours. Like, whatever. Like, I'll be over here. You know, I'm putting this in, but. There's been a few. And wild. We're just like, so one is right. My school stage now. Cloud-based. So instead of having like onboard units and roadside units. They actually matching. Sorry. Yeah. Like this.
Say again?
Officially for 25 minutes or
25.
what is it, about an hour?
Yeah. This session is for 25, 10 minutes of Q&A. So, do you need a 5 in the morning or?
No, it should be fine.
Should be fine? Okay. All right, everybody, can you hear me? Mic check 1. All right, everybody, we're gonna get started. If you please find your seats. Okay, welcome, everybody. This is gonna be technical session 2B of this year's winter workshop. See, he's gonna go first. I'll go ahead and introduce our first presenter. First presenter is going to be Ben Lemke. Ben is the Major Projects Program Manager with GDOT's Office of Traffic Operations. He has a bachelor's degree in civil engineering from Georgia Tech and is a registered professional engineer in Georgia. He began his career with GDOT in 2019 in traffic operations. He has contributed significantly to the SIGOPS and ITS programs throughout his career with GDOT. And in his current role, he is responsible for the procurement and delivery of special projects for the Office of Traffic Operations. Please welcome Ben Lemke. Okay, so.
Good afternoon. Like Raul said, I'm Ben Lemke. I'm the Major Projects Program Manager with GDOT, and today I'll be presenting on Georgia DOT's statewide broadband program. So I'll run through the background of the program, give an overview of it, the different elements of it, talk through kind of the next steps for the future, and then finish off with acknowledgements and questions. So the genesis of the program really points back to 2017. with Hurricane Irma. At the time, it was the most powerful Atlantic Ocean hurricane in recorded history. There was a lot of uncertainty in the trajectory of it and the timing of it, and it resulted in a lot of evacuations throughout Florida. A record number, 6.5 million Floridians evacuated. Also, over 500,000 on Georgia's coast evacuated, and GDOT had to enact the contraflow lane reversal on I-16 for that evacuation. So as you can imagine, with this record number of evacuees, it put a lot of strain and congestion on Georgia's interstate network. And with that traffic congestion also comes network congestion. So the cellular network is a lot like a roadway. It can only handle so much traffic. And with each of these vehicles, you can imagine maybe an average of 4 devices per car, kids playing games, parents, looking at directions, looking for hotels, things like that. And eventually the cellular network just can't keep up. So GDOT also uses the cellular network for our ITS systems, our cameras, our DMS signs throughout these rural areas. And so during this time, we also couldn't communicate with our devices. We couldn't see what was going on out there. We couldn't update messages to our signs. So all that kind of put in place the idea for GDOT to build out a more dependable ITS network and also really expand our network statewide. And so a couple things that we were looking at as we were trying to pursue this more dependable ITS network is asset recycling, which was pretty popular at the time. It was a cost-efficient way to try to build out your network. And that kind of led us towards our first run at this broadband program. So GDOT recognized a commercial opportunity with this, kind of building off of the backbone of Pennsylvania Turnpike. We looked at procuring a design, build, finance, operate, maintain model where kind of the developer would fund the upfront construction costs, and the commercial revenue would be used to pay for that initial construction build out. However, GDOT decided to step back and kind of reassess the approach. So we figured out a few very helpful lessons learned through this first procurement. First off is that the telecom industry is fundamentally different from transportation. They have different needs. So we really wanted to understand some of their restrictions and some of what drives their commercial goals. So we really wanted to step back, realign with the industry. And since then, a few things have happened. Probably most notably is COVID-19, which really highlighted the importance of internet access with the uptick in remote work and remote education. People relied on the internet to connect with friends and family. It was really a backbone to a lot of businesses to maintain their economic stability throughout that time. Also, the IIJA put a lot of funding into last mile broadband. So this right here wasn't funded by the IIJA broadband funding, but IIJA did put a lot towards last mile. And so we felt we had a role to play in that middle mile to support the last mile investments. Also, the market has matured since that initial procurement. Pennsylvania Turnpike, as I mentioned, NCDOT also had a broadband project for over 600 miles of their roadway that they're currently building out. Arizona DOT procured a broadband project in early 2023. And all of these procurements kind of had a few key elements that were similar among them. So one was they constructed with the telecom industry in mind. They looked at using innovative construction techniques. They used this as an opportunity to expand their ITS capabilities, and they all have this OMC model, this operate, maintain, commercialize model. So now into GDOT's broadband program, we really have two primary objectives. One is to have a well-maintained, dependable statewide communication network that can support GDOT traffic operations and future traffic operations technologies. And the other is to leverage this limited access right away to provide that middle mile broadband access, which will also help generate economic benefits throughout Georgia. So our broadband program has kind of two key elements. One is a series of design build projects that will be used to build out the fiber infrastructure, and the other is this operate, maintain, commercialize P3 agreement. So as I mentioned, we'll have a series of design build projects that are installing this fiber infrastructure, and then we'll have a operate, maintain, commercialize contractor maintain that fiber, but also commercialize it. So GDOT, this is just kind of an example of the infrastructure that we're putting in. We're putting in a 7 conduit duct. 2 of those conduits will be for the GDOT network. And the other 5 will be reserved for this OMC contractor to commercialize. So these design build projects, they kind of formed a logical partnership between the Office of Traffic Operations and our alternative delivery, which is now our P3 division, because they are familiar with delivering and procuring these design build projects. And then this is primarily all a ITS scope project. So our traffic operations is the SME for ITS scope at GDOT. So these series of design build projects, we have 5 of them, 5 different projects. And here's a map kind of showing the layout of them. They'll all have similar scope, really the core of it being installing this fiber infrastructure, and then also installing CV to X RSUs pretty comprehensively throughout the state. So the first 2 design build projects, they've been awarded, and the first one is under construction. The second one will start actual construction within the next month. It's currently in design, but those first 2 projects make up about 500 plus miles. It's the I-75 portion and then the I-16 portion with a segment of I-20 there. The third project is the I-95 corridor. That one's currently under procurement and letting in August of this calendar year. And then we have 2 more projects programmed to hopefully build out the rest of our interstate system. That's going to be up to about 1,400 miles once it gets built out. So as I mentioned earlier, the scope is pretty simple. It's really just installing this 7 conduit duct. 2 of those conduits will have a 288 count fiber optic cable in it. One of those is for GDOT operations purposes. And then the other is being pulled to kind of give the OMC contractor a leg up to kind of fast track some of the commercial activities. For GDOT's fiber, we're also going to be installing mini hubs at 40-mile spacing for optical regeneration. And then ITS devices, as I mentioned, it's a pretty comprehensive CV to RX RSU rollout. And then we're also installing some CCTVs to kind of hit some of those spot locations where we're missing coverage. So these design build projects, as I mentioned, they're pretty simple. Kind of the unique thing about them is their length. They're 300, 200 plus mile projects. And that's unique for the department. So we tried to implement a few unique project approaches with that in mind. The first is we looked at simplifying our design build contract. We really wanted to make this an approachable project to reduce barriers of entry. We wanted, firms that weren't familiar with working with GDOT or maybe not familiar working with GDOT on design build projects to see this as an opportunity for them. The second is with regards to environmental, trying to clear a corridor this long. Obviously, we can't do that pre-let, so it has to happen during the project. And so we had a lot of agency coordination pre-let to figure out kind of a way to avoid as much of that work as possible. And so one example is with regards to cultural resources, we have a programmatic agreement that kind of defines the shoulder into 4 different zones. Zones 4 and 3 under the paved shoulder and kind of under the forest slope of the grass shoulder. Those are where there's no potential to affect. And so those don't require any kind of archaeological monitoring while they're installing. Next is with regards to railroads, there's a lot of railroad crossings on a project this large. And if you know any kind of project crossing railroad right away has to go through the process of permitting, have to have a license agreement in place. So what we did pre-let was we reached out to the railroads and negotiated railroad agreement language, kind of a template agreement. That way, whenever the permitting starts and the design happens, then we can quickly get those railroad agreements executed to avoid any delays to the project. The next is with regards to right-of-way. So really, there's some sections of the interstate that the right-of-way hasn't been verified or cleared since its initial installation, especially in the more rural areas where there really hasn't been any build out. So this was an opportunity to do a comprehensive review of the right-of-way parcels along the interstate, and this will also support any future projects that have to come through. With regards to schedule, we wanted to try to look at ways that we could give the design builder flexibility to fast track the schedule. So we allowed them to segment these projects into whatever logical segment lengths that they felt worked best for them, where they could complete the design of a segment, get it under construction while they were still designing the rest of the corridor. We also built in provisions for early material acquisition so they could more quickly order some of that long lead item materials. Also with a project this long, there's a lot of conflicts. And so we wanted to give the design builders much flexibility to avoid those conflicts as possible. So we allowed for in-pavement micro-trenching. This is a construction technique where the detail of it shown right here, but use a saw to cut about a 2 to 3 inch trench that's 1 to 2 foot. And really you can roll right behind it and drop in the conduit. So we're using microduct conduit and microfiber. So it's like a 4-inch total duct. So it just goes right in there. And then you pour it back with a color match concrete. Also with just the design build approach in general, we didn't define a conduit path. So that gives the design builder the flexibility to kind of move to the opposite shoulder and things like that. With regards to maintenance, again, I keep going back to a project this long. It puts a burden on the contractor to have to maintain and protect this infrastructure during the project. So we built in this segment maintenance handover idea where we have predefined segments They're shown in these images here where the contractor can kind of complete that segment, get it tested out and everything, and then turn that maintenance responsibility over to GDOT. And then batch acceptance, that's typically with ITS projects that have a lot of ITS devices. We have this batch acceptance process where we can kind of burn in and inspect batches at a time. And then really, that, you know, as I kind of alluded to, there's a lot of projects that are overlapping these projects just with the length of it. So really project coordination is key on this. And so we enacted quarterly district meetings specifically to discuss these projects, discuss maintenance and construction activities that are currently going on or upcoming, just so it can always stay on everyone's radar and we can try to get ahead of any conflicts with other projects. So now I'll jump into the OMC portion, the operate, maintain, commercialize. This was a P3 procurement. It's a 25-year base contract with 2 optional 5-year renewals. The procurement of it was structured to get the OMC contractor on board during the construction and really before any of the testing for the first design build projects. That way they can kind of participate in that as well. And then kind of the key of this is the OMC contractor will commercialize this infrastructure and make revenue payments back to GDOT. So that will either be in the form of a revenue share, and then at the very least, there's a minimum guaranteed revenue if the OMC contractor doesn't hit that mark with the revenue share. So you can kind of think of the OMC scope in 2 separate terms. One is with regards to the commercial network. There's 5 conduits that they're commercializing, and then one is with regards to the GDOT network, the other 2 conduits on that trunk. So with regards to the commercial network, they're responsible for the operations and maintenance of it, as well as commercializing it. Any kind of build out of that infrastructure, so laterals, hubs, optical equipment, all of that they're building off of this backbone, that will all be done through special encroachment and utility permits. As I mentioned, a share of their revenues will flow back to GDOT. Their commercial network will be open access, non-discriminatory pricing, and compliance with FCC. And then none of the maintenance and operation of that commercial network will require any financial obligations from GDOT. For the GDOT network, we are looking to take advantage of their maintenance responsibilities for the commercial network since we are co-located with them. So they will be also providing maintenance services for GDOT, in which they will be paid a fee for that. So this is outdated. We did reach commercial close for the OMC contractor on February 18th, so just a couple weeks ago. And now I'll kind of jump into the long-term goals of the program. So first off, it's to expand our fiber optic network statewide. So as I mentioned, we have 5 program projects right now that we plan to do that with. The next is to expand our CV RSU capabilities on the interstates. So we're doing that through these design build projects. And then to have a well-maintained ITS network. That's the idea behind this OMC contractors. They'll be providing that that maintenance for us. And then eventually we do plan to transition off of any existing GDOT fiber trunks, transition our ITS assets over to this newly built, newly maintained fiber backbone. And then eventually, once this infrastructure is built, the OMC starts commercializing it, utilizing those revenues to offset the maintenance costs for this infrastructure. So now I'll just run through acknowledgements. this project really had a lot of involvement, both from the procurement of it, the development of it. As I mentioned, it really traces back to like 2017, so a lot before my time as well. But our GDOT leadership has been really influential in pushing the project forward and getting us to where we're at with the program. GDOT offices, I just highlighted kind of the primary offices that really had a very large role in this in these projects and will continue to have a large role. Our pre-let consultant teams that helped really with the procurement of the design builds and the OMC contract. So that's HNTB is our PMC, our GEC is Arcadis, our financial advisors, KPMG, and our legal advisors were Ashurst and McGuire Woods. With the post-let side, the side that's kind of helping manage the design builds right now. Again, HNTB is our PMC, GEC is Arcadis, and CEI is WSP for those design build projects. And then this slide's also outdated, but for our first project, it's the BBH and Atkins team. The second project, that's actually Amentum and Jacobs. Amentum is formerly Jacobs Telecommunications. And then I didn't put our newly awarded OMC contractor on here, but as a joint venture with Plenary and Tilson. Right. And we'll hold questions for the end. Thanks, everyone.
Thank you, Ben, for that presentation. Next, we'll move to Dante Gutierrez. Dante is a seasoned civil engineer with over a decade of experience in transportation and traffic management. He earned his master's degree in civil engineering from Florida International University in 2012, and has since contributed to both the private and public sectors. His career includes roles with the Florida Department of Transportation Arterial Program at the Sun Guy Traffic Management Center and Miami-Dade County's Traffic Signals and Signs Division, where he played a key role in traffic operations at their TMC. In 2023, he joined the city of Greenville to spearhead the development and implementation of a state-of-the-art traffic management center, aligning with the city's vision for a more efficient and technologically, there we go, got it, advanced transportation network. Mr. Gutierrez is a licensed professional engineer in both Florida and South Carolina, bringing a strong technical foundation and strategic leadership to every project he undertakes. All right, everybody, welcome Mr. Gutierrez.
Thank you very much. Can you guys hear me? Excellent. All right. Hello, everyone. Yeah, I'm Dante Gutierrez. I wrote my intro. So I joined the city of Greenville in 2023. I was approached because the city was looking to, for the very first time, build their own traffic management center. And when they asked if I wanted to join the team, I jumped at the opportunity. A little bit of background about myself. As mentioned, I got my master's in civil engineering from FIU, specifically in transportation engineering. I worked in the private sector for multiple companies, including HNTB, well, CHA now. And then I moved to the public sector with DOT, with the arterial management side, managing their TMC from the arterial side. And then I was Miami-Dade County Traffic Signals and Signs Division for 5 years before finally moving to Greenville. So what does it take to build a TMC? First, we had to define our vision. We wanted to have a traffic management center that would serve as the hub to aggregate all of our different data that we obtain from our ITS devices that we have deployed throughout the city. The city of Greenville has a little over 200 traffic signals, which is a lot smaller than the 3,000 signals that I was used to with Miami. But the system here is a lot more advanced because the city has done a great job at pushing to put more technology in those cabinets. So step one, of course, defining our vision, to have this place where we can take all this information, put it all together, piecemeal if need be, then see the whole picture and use that to really improve our traffic operations day to day. Step two, it's going to be how to build it. We're going to talk a little bit about the software, and then, if time permits, about the actual day-to-day operations. Now, how do we achieve all these goals? Because when it comes to ITS and when it comes to a traffic management center, the end product looks cohesive. You go tour one facility, you'll see a bunch of videos on the video wall, some analytics on the side, maybe something related to ongoing incidents. But it's important to remember all of these systems usually are separate individual components that we are trying to put together in a way that flows with each other. And of course, what are our limitations? Well, we're a pretty small team. Right now, the TMC is operated by myself and one operator, and we try to keep coverage from 7:30 a.m. to 6 p.m. Monday to Friday. So we don't have a lot of manpower to work with. And in terms of getting everything built and installed, I was basically running the charge and working with all of our contractors and our vendors. But you'll see what we were able to do with what resources we had. So first, planning and construction. This is the building where the TMC is located. We are in the 4th floor of the City of Greenville's Traffic Safety Building. I think that's the official nice title they chose for it, right there on Halton Road near Haywood Mall. The building contractor, Hogan, I was in the meetings with them every 2 weeks. I was working very closely with them so that if there were any issues, anything that we needed as we were building the TMC, we had open communication. We were able to hash out any issues, and we were able to plan everything. We're going to see building a TMC is more than a building because there are infrastructure requirements, there's communications, there's certain specific things need to be installed, but that has to be done after certain parts of the building are built, and that has to be done before some other parts come in. So just trying to manage all these moving parts and schedule them in a way that would not cause delays to our project was in of itself a logistical challenge, but one we managed to do. Like I said, we had the building contractor, we had the video wall contractor, and then we had some other vendors that we're going to look into. So to give an example, this is a floor plan for the traffic management center as it was originally designed. As you can see, we already had a general idea or where we wanted the workstations. The video wall you can see here on the left, it's labeled that as 24 feet long. And may not sound like much, but even the placement of the workstations was important because as we're trying to run cable down to the data center from each one, we needed to figure out exactly where we needed to drill boreholes. That might not be something you think about when you're trying to come up with this, but even the specific locations of drilling boreholes through concrete slab all the way down, back to the data center, up back to the back room of the TMC, all of these little details we needed to plan ahead. We needed to think about, we needed to measure so that everything as built could be done with little issues or having to cut anything again. So let's talk about what we needed, right? I mentioned we need to connect to a data center. So we needed to also deal with our IT department. We wanted some ergonomic workstations. We understand our operators and myself are going to be working on these every single day. Sometimes we want to be sitting down. Sometimes we want to stand up. We ended up getting some nice sit-stand stations. We wanted a conference table in the back, and everything needed to be done and nice and to be free for the video wall before the installation. So as we go along, you're going to begin to see how all of these components needed to be done in a certain sequence. So let's talk about building. This photo right here is around the time really the meat and potatoes of the project started. But as you can see, it's concrete floor, a painted wall, nothing much to show for it. A little bit of time after, they put some carpet, everything's beginning to look nice. We got our workstations up there. Now we're looking better. Now you see what we're dealing with. Finally, we have a video wall. And the back room there has a server We're gonna get to that as well. But what's a video wall for, right? You might think, well, that's where you guys see the videos. You guys go to any TMC, normally you're gonna see something like this, right? You got video streams coming from a bunch of cameras. And like I said, maybe a map here, maybe some analytics. Well, wanted to do a little bit more than that. So let's talk about the video wall. It was provided by Heyvision. It's a 6x3 screen video wall, 20-foot long. One interesting, cool thing about it is that rather than the traditional giant screen that is connected to a computer in the back, you know, one-to-one stream, it actually utilizes IP stream from any number of sources up to some arbitrary limit to display on the video wall. What that means is that within one single video wall display, I can have a computer, multiple workstations, and multiple other sources streaming from different places onto that wall. You won't know what's coming from where, but when you're looking at the end product, once again, everything comes together to a nice cohesive display that we have a great control over. We can create different settings, we can create different layouts as needed for whatever we're trying to do. That's the information I just went over. So this is the cabinet we have in the back for it. It looks pretty small, but it controls the video wall. It controls a computer that is embedded into the wall, and it also has its own data streaming server for RTSP video from our PTZ cameras. I'm very proud to say that one of the cool features of our video wall is we can stream directly from the PTZ cameras in the field to the wall without needing any other computers attached to it, on top of everything else that we can display. This is what our workstations and our conference table look like. Again, doesn't look that impressive, but I will in Rex to develop these. Like I said, sit and stand, ergonomic. They allow for some privacy panels because we understood people don't want to be staring at a video wall the entire time, but for the eyes. And we even had the luxury of being able to determine where to put special grommets to be able to connect everything right through the workstation onto our computers to minimize cable mess and to give a little more functionality to our furniture. There again. All four workstations actually have two connections to the video wall. So if you're sitting at a workstation, you can plug in an HDMI cable that's coming out of it, and you can stream directly onto the video wall from your workstation. That's come in handy many times whenever we're trying to present or display something specific that is outside of our regular video footage or maps that we saw earlier. And of course, operator and user comfort in mind, because we want this to be a place where we work, we're comfortable, we are able to stand if we need to, sit down if we need to, so that we can do a good job every day. Let's talk about software. So, like I mentioned, hello? Like I mentioned, one of the biggest challenges of a TMC is managing all the different software components that we have. I mean, our cameras, of course, have video and loop detection. We have Bluetooth data collection deployed over a large network throughout the city. We also want to be able to check what the health of our system is, what locations are down, where are communications failing. We want to show everything on the video wall. What can we do with our central controller system? And what else can we do with our PTZ cameras beyond just having a wall where we just see cars every day? So we're going to go through each of these one at a time, but I'm going to be giving a little more time to some because they're the most important ones. So first off, let's talk about our central control system. That is the most important part of our operation. The central software system is what allows us to remotely connect to our controllers if we need to make any emergency changes. We use ATMSnet now. That's what SCDOT uses, and it's been good so far. Not much to say about that, honestly. I mean, we'll get to that. For our cameras, we use PTZ cameras. They are deployed in about 50 different locations. We can stream directly to the video wall. We also have a video management system. And we can use that to view the traffic in real time, and we can move the cameras around and zoom in to get specific details if needed. Usually this comes in handy whenever we're trying to evaluate any crashes or any special events to see what the impact of traffic is. Here's a picture of our video management software, for example. It cycles through our cameras 25 at a time every 5 minutes. Within a 10-minute span, we can see the entirety of our city. This specific one is desktop version. It was coded by our team, and it allows us to take the feed from our PTZ cameras and display them in a tile setting. We use GridSmart video detection at certain locations. They also allow us to get some amount of visibility on our signals. It uses virtual detection loops to let us know when there's vehicles, and it can assign timings as well. Our Bluetooth network that is deployed throughout the city, it is very expensive, and we use it for travel time and speed collection. It also stores historical data to create a rolling average. So on any given time, we can compare our data to the historical data. So the historical data is important because whenever we make any changes or whenever we're trying to assess what any incidents did to our system, we can very easily pull it up and compare that to what a 12-week average was. We also have a system in place that alerts us whenever that travel time goes over a predetermined threshold so that we can keep an eye on our system and see, hey, what's going on? Speaking of connectivity, over 60% of our signals are on communication via fiber. That means that over 60% of our signals are ones that we can see live and we can react to. But when we have that many signals, it's also important to know which ones are working and which ones are having communication issues. This is Maximus. This is a system that we also developed that allows us to check the health of our system. Every 5 minutes, it sends up pings to all of our controllers and all of our cameras and lets us know where we're having any faulty connections issues. Also, it sends an API request to our Bluetooth system so that we can know if any of our Bluetooth devices are having any issues. With this system in place, we're able to tell within 5 minutes of an issue where communication problems are happening so that we can evaluate and deploy as needed. Now, the video wall runs on Command 360. It's a software that was developed by Heyvision. It is browser-based, so we can actually control the video wall from any of our computers. We can even control the video wall remotely from outside of the DMC in case of an emergency. So, as I mentioned earlier, from a distance, it just looks like one single display. And here, as you can see, we have multiple items being shown. I'm going to label them right now. We have freeway cameras, we have system health, we have the 501 map, we have arterial cameras, we have PTZ cameras, and we have a Bluetooth map. So very briefly, on the top left, you can see the freeway cameras. Those come from 511, and those are important because we have several locations at arterials that are touching the freeway, the ramps. So this has happened many times. If there's a crash on a freeway or something that is causing people to detour out of the freeway onto the arterials, suddenly dumping all the traffic, we're able to see it right away so that we can react, maybe make some on-spot timing changes to help flush all the traffic out. System health, it's so that we can see if there's any issues with our communication. Some locations are linked to others by comms. So if one key location suddenly were to go out, it would actually show us multiple locations on our map. That also helps us diagnose where to go for any repairs. The SC501 map lets us know of any incidents that are happening throughout the city and mostly for freeway issues. The PTZ cameras that you see on the right there, those are the ones that are enabled directly with fan tool zoom controls. Those we use whenever we want to really focus on some locations, like if we're evaluating PM peak conditions and we want to actually move around, see what the traffic downstream and upstream of a location is. Finally, we have our Bluetooth network map there, and then we also tune into the news in case there's any major events that we need to look at right now. Now, DNC operations is one of the most important parts of what we do, right? We have already a plan in place. Looks like a very long chart, but the basic part of it is we have different places where we can get our information from that we can use to identify any issues. If we see that there's something that we can do, usually by making some timing changes, we observe, we deploy, we iterate as needed. And then once we have seen the traffic is able to return to its previous condition, then we are able to revert everything back. Traffic can operate back to normal. Like I mentioned, one of our inputs is the freeway cameras. We have them shooting at the locations where we have ramps that are going to arterials. We have identified 4 locations on 385 that are connected to our arterials via ramps. So we use that to focus really on events that might impact traffic. We also get notifications directly from 511 via email. I had set something up so that we get notifications for those key freeways near our ramps. So if there's a crash, I know right away. And I'm proud to say one of my biggest wins has been that we had an incident one time that 5 minutes after we received that alert, we were already implementing timing changes on the field remotely to be able to flush traffic out. It's allowed us to really reduce not just how long these events last for, but also reduce the impact it has on the neighboring traffic, as we're able to increase the split on certain key movements just to flush all the traffic out. The recovery shortens substantially. We have a police scanner as well. The police scanner lets us know if there's any crashes or any incidents within the city. Normally, they happen along the arterials, so that lets us know, hey, we just heard that there's a crash, there's an incident going on at such location. Let's put our camera right there. Let's tune in. Let's see what's happening. Again, there's been multiple times, especially in the evening peak, where we've been able to acknowledge a crash or some sort of major traffic event because of the scanner before something like a Bluetooth devices were able to give us an alert. So we perform active traffic management this way. We have traffic monitoring. We have partners with police and fire so that they can give us access to that scanner. We also receive calls from the public, which we log and we field. And then based on all of that, we're able to improve the traffic flow throughout the city. So building the TMC was one step and operating it is another. We're still expanding what we are doing with our system. I am very proud to say that the work that we are doing right now is allowing us to really not just improve traffic, but help the public in a way that unfortunately they don't really see, but they can definitely feel. I always say that if you do your job right, people don't think you're doing anything at all. And in a way, that's been my goal. I want people to not even notice that there was a crash no more than a few minutes ago because we were able to dissipate traffic flow that quickly. Ultimately, we're still expanding. I'm looking to get more operators. My end goal is to have a system where the entire world, the entire system in a way talks to us. I want to know if there's an issue immediately, what's going on, where is it, how it's affecting our travel times and operations. I also would like to expand maybe even to weekend operations and of course do extra timing plans for special events. I've been working very closely with the Greenville Convention Center at creating special timing plans for events. That has been another great thing, that having a traffic management center, being able to have eyes throughout the entire city or entire network is allowing us to do. Even smaller traffic events, such as the egress of a, I don't know, technical conference might have on the traffic signal system on the nearby area. So I know I ran a little bit quicker than I intended to for this. I really do thank you for your time. I would like to answer any questions you might have. I'm going to be honest, a big part of building this TMC has been just learning on the fly how to manage and solve issues that I hadn't even thought could come up. It has been a great exercise in project management, in traffic engineering, in technology, even in coding. Some of the applications that you see on this video wall, I helped create from scratch with just some knowledge of coding functions, API calls, which to me is one of the most exciting things that I've done in this job and something that every day I'm trying to push for. I'm at a point where I really want to test the capabilities of a very advanced system. I'm even dabbling with, can we maybe find a way to route the stream from our PTZ cameras through our server directly into the video wall? Can we see the detection on the wall itself? Can we create our own dashboards to see live travel time displays on it, not just a little map there that you see of travel times on the wall? So I think that if there's something that I want everyone here to take from my admittedly quick presentation, is that building a TMC is a true unity of infrastructure, technology, operations, and adaptability. So thank you very much for this opportunity to present, and I'll be happy to answer any questions.
Thank you for that wonderful presentation. It does look like we have plenty of time for questions. Are there any questions in the audience for either presenter?
Right, great question. Do you want an answer from the building it part, or do you want an answer from the operational side? All right, so this is actually a funny one because we had just gotten our operator to start working. This happened shortly after Helene's impact. As you guys know, Helene kind of hit the city and we lost power pretty much everywhere. And we actually are still suffering some fiber comms issues since. So we had our operator start around October. I want to say on his third day of working with us, there was a major crash on 385. They closed down the entire freeway at that point, and they were dumping the entire AM peak traffic onto a ramp on Lowndes Hill. So you had whatever the volume is that on a single left turn lane program at like 35 seconds and 170-second cycle length in the AM peak. A nightmare. Thankfully, we were there, we were live, we were operational. The way that we caught this issue, as it would so happen, is because I was explaining some stuff to my operator, and he goes to me, "Hey, what's going on over there?" We turn our faces and we see the camera that's hitting at the ramp. Hold on, let me show you which one. All right, the top, there it is. The top right camera, that one, all of a sudden, traffic going on the, I guess, going up, right? Yeah. Direction, the southbound direction, completely backed up, out of the blue. He's like, what just happened? Immediately, as soon as I say that, phone rings. It's one of my coworkers letting me know that there's been a crash and the police is there. At that point, I'm like, oh yeah, no, we already saw it. So we get to work. We pull up our maps. We identify which locations have signals at the ramps that are feeding off of it. Pull up our camera, move it around, focus on that movement. Lo and behold, it is completely backed up. So let me see here if I can get a picture of the video on the video wall. Yeah, so you see the video wall there. So I tell my operator, okay, what you're gonna do is you're gonna take that location. You're gonna put it on the video wall as big as you can, one of those corners, because I need to see how far back that's going. So we went from little display there on the video wall, now large display on the side of the wall. We're able to see what's going on. I told him I need to move the camera around whenever you can because I need to see traffic that's flowing out and also traffic that's flowing in from that signal. So while he's doing that, and I'm telling him every like 2 minutes, take pictures or whatever, document what's going on because we're gonna need to show what happened with that queuing. I'm gonna just fast forward a little bit here, rewind. We have travel time, we'll get to that. So anyway, so that's all happening. And let me see where's others. I go onto our central controller software. I identify the location, edit, start making some changes, have to do a little bit of math of how I'm going to move the splits around. Over 3 iterations, I increased that 35-second split for that left-hand movement all the way to 60 seconds per cycle. Starts flushing that traffic out, right? We're getting traffic out. Unfortunately, upstream of that intersection, people are still coming to the highway. Unfortunately, at the time, nothing we could do. So best thing we can do is people are gonna get stuck. People are gonna try to use the ramp. Let's flush them out as much as we can. After we start getting people going that way, we identify, okay, they're gonna go from this point down to this next intersection. So we're suddenly dumping a bunch of traffic. We're going to also be increasing the left turn split over there to help create this detour route, right? This makeshift detour route to get people onto Haywood so they can then take 385 off of the next exit. We were able to do that. And once the lanes reopened, there was not a lot of lane demand because we were able to manage it throughout the event, throughout the traffic event. Things recover, we were able to revert everything back. And after that, we are looking at our travel time. We have the Bluetooth, and this is obviously not the exact graph, but it's emblematic of how we were able to determine, oh, look, here's the event. And as you can see, this would have normally been a massive like gridlock event, taking Canos how long to recover, probably broken multiple corridors. We were able to act on it immediately and efficiently. We were able to see that dramatic drop. So we saw all that buildup and then this precipitous drop in travel time as the lanes reopened because traffic had been flushed out during the event itself. All right. Yes. We do have fiber. As I mentioned, we have it deployed through around like 60% of our locations. So 134 traffic signals are on fiber communication. Yes, sir. We have been approached by vendors about that. At this time, they cannot, but we are exploring that option as well. The main thing about it is it's not just a matter of creating the camera, those also need like their own processor in the cabinet itself. Yes, sir. Well, this was built from scratch. So we didn't have a previous location that we moved to. This is our first TMC. In terms of lessons learned, the scope for this project was written and agreed upon before I joined. So there were a couple of issues that we found after the fact that unfortunately I inherited the responsibility of fixing. And one of them had to do with how we handled real-time stream protocol, or DSP streaming from the cameras to get onto the video wall. It required a lot of back and forth work. It required me to overnight have to become an expert on video streaming protocols. But through that and coordination with Heyvision, we were able to come to a solution so that we could basically do some reconfigurations of our portables video streaming server. The unit's called the Kraken, that's what they call it, to be able to ingest the stream from all of our cameras and simultaneously display them on the wall. That is was on itself a challenge, but something that we were also able to resolve. And in the meantime, we were able to also develop our own video management system, the one that you see on the wall. So in a way, we actually have two different ways to view our cameras on the video wall, and then move stuff around as needed.
Time for one more question, if there's one out there.
Hey, thank you.
All right, guys, that will conclude technical session 2B. As a reminder, I think next we have, oh, If you did not sign in, please sign in sheet. Ragu is holding it up. Please sign in. Next is dinner. I believe that starts at 6:15. So we'll get you out of here a few minutes early, let you get a few more minutes before dinner starts. Thank you.